There's a story in the history of mathematics about the mathematician Gauss, who in a childhood setting in a school, he was given the task, or the whole class was given the task of adding the whole numbers from 1 to 100. And most of the students started out by taking 1 plus 2 got 3, then 3 plus 3 got 6, and then continued on, working from the bottom of the list up. But Gauss wrote down a solution right off the bat and turned his slate over. The schoolmaster was thinking that he hadn't done any of the work, but when he turned it over, Gauss actually had the correct total for that process. Well, let's look at what Gauss thought of going through this process and see if we can use that to help us get shortcuts to the summations that we will be using in a later type of problem. Well, what Gauss, in the story that goes along in the history, saw was that if he took the first number, 1, and added it to the last number, 100, he got 101. And then when he took the second number in, 2, and added it to the number right before the last one, 99, well, 2 plus 99 also gave him 101. And 3 plus 98 also gave him 101. Well, each of these sums of those numbers working in were giving them the same total. So he figured he was getting a total of 101 when he paired the numbers like this. And since there were 100 numbers, he needed to take that 101 total and multiply it by the 100 number divided by 2 because he took the numbers in pairs. So he actually had 50 pairs of that total of pairs of numbers that gave him that total of 101, and when he took 50 times 101, he got 5,050, wrote it down in his slate, and that's actually the total that it should be. Well, this process doesn't only work when you're adding these numbers, but it also works if your total is out to whatever value you want to stop at, but you're to add the integers from 1 on through. So the rule we can write for that is the sum k equals 1 to n, wherever they tell us to stop, of just k, because that would tell us to put 1 in, plus 2 in, plus 3 in, plus 4 in, up to n. I can get there quicker by taking, well, the total was just 1 more than where he stopped. So we have that n plus 1 that we would get for our total of the numbers taken in pairs. But we would have n divided by 2 of those totals because we took our numbers in pairs. So that formula actually is n times n plus 1 all over 2. Now in another segment, we're going to take and write out formulas for several different summations and then show how these can be used in a process that we're going to work with in terms of limits of summations.